so if we want to take this into ANSYS, actually anything we want to do to get this over to ANSYS, we need to save it first. So you can run into issues and it just won't show up and stuff like that. It may or may not give you errors to help lead you in that direction. Easiest thing to do is just save this. So I'm going to go ahead and save it as part 5. So this was the 5th one on the sheet. I'm going to save it as part 5. Oh, I already have it in here. Look at that. I just have it in my downloads folder because I can save this for next time. But anyway, save it to your favorite folder, whatever name you want to give it. We'll save this up so we can replace it there. All right, so it's been saved. And so if we want to take it directly into ANSYS, if we have this menu up here, we can take it in. It's just come up here with ANSYS Workbench and click on that. And ANSYS isn't loaded. I didn't have this loaded already, so this is loading it on my machine for the first time here. So it's loading up the Workbench project page. So this is where we kind of add things or kind of connect things where we want things to happen. So what it did, it loaded in the geometry in this plain old geometry box. So they're not going to do any analysis with this as it's shown. It's just straight up just geometry by itself. So we need to tell it what kind of analysis we want to do. And for this one, because we're going to be loading with pressure and just looking at the overall structural analysis to it, this is a static structural analysis. So here's the analysis here. So we just need to click and drag it over. It shows you the different possible ways you can drag it. We'll just drag it right here. Let's create a standalone system and let go. Let go of the button. And it'll load in here. And it's going to already have pre-populated with the engineering data, and I'll show you what that is in a second. But the thing we want to do is, because this brought it in directly from SolidWorks, we want to click and drag it over onto the geometry. And that'll connect it up like that. Now the other thing I said was we could do this without having any ANSYS integration with SolidWorks. So if we do it in some other software program, or we have it in SolidWorks, we already did it and we saved it, and now we just want to open ANSYS by itself, we don't want to have this automatic integration piece, that's fine. The way we would do that is we bring in the static structural like I did just now, and I'd right click on geometry, and I'd have replace geometry, and it's already connected here. So let me go over here. This will be functional, be available. Now let me just do it like this. So I'm going to delete this, delete the link so you can see here. So right click on geometry. Didn't like me right clicking twice, I don't think. All right, so now we want to replace geometry. And so we can come in here and browse and find our part. So you can still just save in SolidWorks, bring it in here if you don't have the integration set up right. But just, again, right click on geometry and just come in here and you can draw in here. ANSYS also has Design Modeler as its own 3D modeling program. I think it's extremely clunky. It's great for really small geometries you want to do, and maybe some specific ANSYS conditions or setup pieces are nice to do with it, but it's usually best to draw it somewhere else and then bring it in to finish it off in ANSYS. All right, so I'm going to reconnect that up here. So we have it from the original thing. All right, now I said I was going to go back into engineering data. Let's do that. I'm just going to double click on engineering data. And so what it is the data, what kind of materials are we going to bring into the analysis? And so this one is showing that structural steel will be brought into the analysis. And if it's already highlighted, so click on it without changing the name. I come down here and we can look at the Young's modulus is 2 to the 11th pascals. All right, so we're expecting a structural steel with a modulus of 29 times 10 to the 6th pounds per inch squared PSI. So let's come in here and change the units to make sure that's what we got here. So there's PSI. And we got 2.9 times 10 to the 7th. Yeah, so that's 29 times 10 to the 6th PSI. So we're good there. This will work. If you wanted to add another material, you can come over here to physical properties. These are things you could define specifically, but if we wanted to look at adding a different material other than structural steel, we could click here to add a custom material. Or probably the easiest thing is come up in the data sources. So I just clicked on data sources. And here's one that can be used a lot, so we could just click on add. So you'll see the book up here next to it. Other things, if we drag this down here a little bit, so look at some general materials. They pop up here. Aluminum is often used, so aluminum alloy, click plus there. All right. So those all look good. So anyways, once you add them all, now you can click on engineering data sources. It'll hide them, and they'll show basically the three here. All right, and these will be the three that it brings into your model as available materials that you can use. I'll show you how you can pick those once you get into the analysis place. But it doesn't mean you have to use them. It just means they're available. So those are there for the next time we go into our schematic. So I'll go ahead and close this. Everything's already saved. And now ready to go into the model. I'll double click there. All right, and there's my model. And I can left click to select different spots. I can middle click and rotate. So similar features to SolidWorks. All right, I can right and middle click, or sorry, control, middle click, and pan around. And if you want different views, probably the quickest way is to right click and go to isometric view. You can get that view. If you want to get one of these face views, nice thing to do is come over here to the triad and click on which face you want to view. And you can click and see the different faces very quickly. And you can see how it's positive Z. If I come down here, I can get negative Z. If I slide down there, so I get the negative Z. And this little ball here is the ISO, so I can go back to ISO view. So ultimately, I want to look at what's happening on the orthogonal to the Z plane, or Z axis. So I'll click on that one. And maybe zoom out a little bit so I can still see my scale at the bottom. Zoom out in pans. Let me get back here. Zoom out and I'll pan it up here a little bit. There we go. See everything okay. What we're going to do is we're going to work our way down this tree on the left-hand side, or outline. So you can expand the body, and you can see that part 5 is there. But what I want you to notice, when I click on part 5, I can come down here and define a material assignment. So it's already set to structural steel, but I also selected air and aluminum. So if I click on structural steel, I can see here that I have air and aluminum alloy. Now I can also add a new material. I can import, I can edit structural steel. But here's how I can access that, apply those back there with engineering data, and then I can come in here and select the ones that I want to use. So I'm going to keep it with structural steel, so that looks good. And come in here, and we got to start putting on boundary conditions on this thing. So let's come here and click on static structural, because that's the type of analysis we're doing. So it wants what kind of boundary conditions for that analysis. And so it brings up here what's available. So I can do some different types of conditions, supports, loads, and inertial aspects that we can apply to it. So from our handout, we know that we want a fixed support here on the left-hand side. So let's turn it over so we can access that panel. And we can click on it now, or we can click on it once we've done the support here, but I'm going to click on it first. And I'm going to come here and I'm going to say I want to apply a fixed support to that. So I'll click on fixed support. And you can see for the geometry selection, it says you've already have one face. So it's already got fixed support applied to this purple face. And that's all I need to do. So that guy's all set up and ready to go. I'm going to do a little bit differently for the next one. I'm going to go to the loads, and for the pressure loads, that's the other side here. So I'll click on pressure. And so now it's asking me, hey, where do you want to apply it? Which face do you want to apply? Because I didn't give it one. So let's rotate it over, and I'll select that face. Now it's still not accepting it because I haven't applied yet. So you got to make sure once you select it, even though I'm already in the details of pressure, I need to apply it so it captures it. And you can see the color change kind of indicates what's going on there. All right, direction looks good. I want the pressure to be 1,000 psi. So I can do 1,000 there. And hit enter. That looks good. Ramp, that's fine. It'll get up to it and it'll show me the ultimate stress that's been applied to it, or caused by the pressure force. And we could do the mesh. So let's look at the mesh here. Coming back to the mesh, we can just go ahead and update. And we can also right click on mesh. You can hit update or generate mesh. So go ahead and do that. So generate mesh. So you can see a very, very, very coarse mesh. We want something definitely finer than that. So we'll come in here and we'll do the relevant center. We'll go from coarse to fine. And now it says the obsolete mesh because we just updated the relevant center. And we'll come in and update the mesh. All right, so that looks better. Let's see what we got here. Oh, got a warning. All an update. Expected errors occurred. Oh, I was trying to do something else at the same time. All right, we're still good. So we can come in here. Oh, by the way, just what was showing there. So we got this. The messages shows you, give you some idea about what errors are due to. So it's kind of a nice feature. Sometimes it's helpful, sometimes it's not. All right, so come back here. We'll do statistics. Kind of see how many nodes we have. So again, this particular license we're restricted to under 256,000. So we're not even close to that at 33,810. So we'll be good with what we have. And we'll just start with this. In future presentations, we'll talk about how we can refine the mesh and where we want to do that. All right, so that looks good. So I think we're ready to solve. So we'll just come down here to solution and go ahead and right-click. Right-click on solution and solve. There's also solve up here at the top. That was yellow at the time when I clicked on it. All right. So there we are. Solutions all done. We can't see anything, right? Well, we didn't tell it what kind of plots we wanted to see. So we come up here and we say, hey, we want a total deformation plot. I don't care about a particular direction. I want to see the total deformation. So I'm going to click on that one. And I also want the equivalent von Mises stresses. So look at that. That's going to be my comparison between these different types of parts, how much stress they show. So click on that one. All right, and it's got these lightning bolts, which says we don't actually figure these out yet. We don't need to resolve it. We just need to evaluate the results from it. And so there we get the overall deformation that's happened. So that's the overall deformation. So we get 0 to 0.0046. We don't know what units there are because they're up here. So that's in inches. All right. So make sure we see the units displayed there. And we can see the distance here on the, well, I guess you can't really see. It's probably exaggerated a bit. Equivalent stress, we click on that, and we can see the equivalent stresses that are showing up here. So we get up to a maximum of 6,600 PSI, and probably happening right in there. If we want to see where that max stress, we can come up right here. Nice little quick way of pointing out the max stress. So it's finding it here on the bottoms. That's probably symmetrical. It's right up in there too. All right, and we can look at the minimum stress being there at the corner. Not affected much by the pressure force being applied. All right, another nice thing to see here is on the animation piece. So it said it had a ramped pressure force being applied to it. You can hit play and you can see what happens in that in the time that it applies the force. See how the stress gets distributed throughout the piece. All right. So just one other feature I want to show you as you do these. So you can go ahead and save this if you want. But usually if I just go ahead and close this, it'll save the results. And I can go back and ANSYS project. And if I double click, so it sees all the way, the green check marks kind of just follow that path. So it already has the results still saved in there. So I double click, I should be able to go back in and have my results there. Click on equivalent stress and it pops back up. All right. And again, if I want to, I haven't actually saved this to a particular location, so I'll come up here and save project. And again, I'm just going to do it in my downloads folder and say my, this is going to be part 5. All right, save.